Hello everyone, this is Jayashree Bhangre, working as Assistant Professor at Maratha Vidya Prasarak Samaj, Nasik. Welcome to the second part of Microcontroller Architecture and Programming. In this part, we are going to learn about the internal block diagram of 8051 and we will see the function of each block in detail. So this is nothing but the internal block diagram of 8051. This is an important block of the 8051, that is ALU, Arithmetic Logical Unit. This is what actually does the data processing. This ALU is 8-bit wide and that's why we are called as 8051 is an 8-bit microcontroller. All the arithmetic and logical operations, they are performed in this block. 8051 has 5 interrupt sources: int 0, int 1, tf0, tf1, ri, ti. So this is interrupt control unit which controls the two external hardware interrupts, that is int 0 and int 1, and 3 internal interrupts tf0, tf1, ri and ti. 8051 has 4 kilobytes of a on-chip ROM and it is expandable up to 64 kilobytes. It has a 128 byte of a on-chip RAM and it is also expandable up to 64 kilobytes. Then 8051 has a two 16-bit timers, timer 1 and timer 0. They are used to count the clock pulses of the CPU. These two timers, they are also used as a counter inputs to count the external pulses. They are connected to pin T1 and T0. The next important block is the serial port. This block is used to transmit and receive an 8-bit data serially. To perform this operation, these two pins TXD and RXD are used. It has 4 input-output parallel ports: port 0, port 1, port 3, port 2 and port 3. All these ports, they can be configured as an input port or as an output port to connect the 8051 microcontroller with the external physical world. If the external memory is not connected, then port 0 and port 2, they are used as a general purpose ports. And if the external memory is connected, then port 0 and port 2 acts as a multiplexed address and a data bus. This is the dual role of the port 0 and port 2. Port 1 and port 3, they are used as a general purpose ports. Next block is the bus control unit. It is used to control data bus and address bus. And these are the signals, they are used to control these buses. The last but very important block, that is nothing but the oscillator. Oscillator is used to decide the speed of a CPU, or oscillator is used to generate the clock for a CPU. So this clock signal allows the operations inside the microcontroller and the other parts to be synchronized. The clock generator is an integral part of the microcontroller and the user has to provide the additional timing circuitry in the form of a crystal. So this is nothing but the crystal. We can connect different frequency crystals to the oscillator. The range of crystals we can connect to the oscillator from 1 MHz to 20 MHz. As we want to higher speed of operation, we can connect the higher frequency crystal to the oscillator. This is nothing but the detailed internal block diagram of 8051. So here is the main processing unit, that is ALU. It has the supporting all special function registers, PSW, accumulator, register B, stack pointer, then program counter, DPTR. These are the special function registers. Then port 0, port 2, port 3, port 1. Here is the RAM, then timing control circuitry and oscillator. So let's see each block in detail. So first special function register is A register, or that is called as an accumulator. It is an 8-bit wide register which is bit addressable, whose address is E0H. Mainly this register is used to transfer data, and this is used in arithmetic and logical operations. After any operation, result is stored into the accumulator, and that can be accessed through its SFR address, that is E0H. Upon reset, its value is 00H. Next is B register. This is a general purpose register. This is also an 8-bit wide register and a bit addressable, whose address is F0H. Mainly, it is used with accumulator in the multiplication and division instructions. It is used as a temporary register and can be accessed through its SFR address, that is F0H. Upon resets, its value is 00H. Next important SFR is PSW register, that is program status word. This is an 8-bit wide register, and this is also bit addressable, whose address is D0H. This is a special function register, and it consists of a different status bits that reflect the current status of the microcontroller operation. So these are the special bits of the PSW. Let's see one by one. First bit, or the 7th bit, is CY, that is carry flag. This flag is set when there is a carry generated from bit 7. Otherwise, it is cleared. And this flag is generally affected in addition and subtraction instruction. Next bit, that is bit 6 of PSW, is nothing but AC, that is auxiliary carry flag. If there is a carry from bit 3 to bit 4, or we can say that if there is a carry generated by lower nibble, then this flag will be set. Otherwise it is clear. And this flag is generally used in BCD instructions. Then bit 4 and bit 3, RS1 and RS0. These are two register select bits. Actually 8051 has an internal RAM that is divided into different sections, out of which the memory 00H to 7H is divided into different register banks, bank 0, bank 1, bank 2 and bank 3. And these bits are used to select the particular bank out of 4 bank. So here we can see that the configuration of bit select the particular bank. So 00, when these two bits are 00, bank 0 will be selected, whose range is 00H to 07H. If RS1 is 0, RS0 is 1, then bank 1 will be selected. If RS1 is 1, RS0 is 0, bank 2 will be selected. And if both bits are 1, 1, then bank 3 will be selected. Then next flag, that is B2, is a overflow flag. If the result of an 8-bit operation is greater than the 8-bit, that means sign flag gets affected in the operation, that time overflow flag will be set, otherwise it is cleared. Then bit 0 is a parity flag. It decides or it shows the parity of the given data. So in given data, if the number of ones are odd, then this bit will be set, and if the number of ones in the given data are even, then this bit will be 0. Then bit 5 and bit 1, these are two user defined flags. Next SFR is DPTR register, that means data pointer register, which is a 16-bit wide. As we know that 8051 is an 8-bit wide microcontroller, so this DPTR register, 16-bit DPTR register is constructed using these two 8-bit register, that is DPL and DPH, means data pointer low, data pointer high. These are the addresses of these two registers. 82H is the address of data pointer low and 83H is the address of a data pointer high. So this register is used in operations regarding external RAM and some instructions involving code memory. Besides, the DPTR register is usually used for storing data and intermediate results. Upon reset, its value is set as a 00. Next important stack SFR is stack pointer. This is used for stack memory. So stack refer to an internal RAM used to store and retrieve data quickly, and stack pointer is the register is used to hold an internal address which points to the top of the stack. So if we want to store the data onto the stack, then first stack pointer is incremented and the data is stored into the stack. If we want to retrieve the data from stack, then first data is taken out and then stack pointer is decremented by 1. So upon reset, the value of stack pointer is 07H. Next register is PC, that is program counter, and remember this is not a SFR. This is a 16-bit register. PC is the only register which does not have an internal address. Actually, it holds the address of a next instruction to be executed. Immediately after its execution, the value of the program counter is incremented by 1. Upon resets, its value is set as a 0000H. Next important block of the 8051 is ALU, that is Arithmetic Logic Unit. This unit is used to perform all arithmetic and logical operations such as addition, subtraction, multiplication, division, ORing, ANDing, XORing, rotate, complement, etc. It manipulates 8-bit and 16-bit data. So here are 4 ports of a 8051, that is port 0, port 1, port 2 and port 3. Each port has an 8-bit, so we have a total 32 pins to connect 8051 with the external physical world. So each port can be configured as an input or as an output port. So in next video, we will see the function of each port in detail. Here are some questions based on this topic, that is, draw the internal block diagram of Intel 8051 and explain any one block. Describe the flag register of 8051 microcontroller. State the use of A and B register and explain how will you select internal memory bank with a suitable example. Thank you.